June 2015, Core 1, Question 3. Lots of work to do here. Now, I had quite a lot of people that didn't read the question here. You're being asked to find the tangent to the curve at point A. So if you think about this, the tangent to the curve at point A would look like that. We're going to have to do this by differentiating. Lots of people tried to find out the equation of this line here, this AB here, and we really didn't want that one. It doesn't help at all. So now you know you've got to differentiate it. Let's get our 2 marks for differentiating. Times by the power, power goes down by 1. Times by the power, power goes down by 1. Our 2 marks there, the 2 disappears. Point A has got x equals minus 1. So we keep going, at x equals minus 1, dy by dx equals, put a minus 1 in here, makes minus 4, put a minus 1 in here, makes minus 6. We have a gradient here of minus 10. And again, let's emphasize this word here, tangent. So we are using that gradient, we're not doing the normal here, we're not flipping it. It says an equation here as well, so let's just go y, take away the y number, equals gradient, x, take away the x number, minus 1. And let's stop there. We don't need to do any more than that, because it says an equation, that is an equation of the tangent. Second part of this then, so you've got your 4 marks there, but now we'll keep going and look at this bit here, is to do the integration. And I'll just extend that page down a bit because I'm going to need some more room to do this. Integrating this, the power goes up by 1 and we divide by the new power. The power goes up by 1 and 3 divided by 3 cancels out. And the power goes up by 1, so we just get a 2x. So you get 2 marks for doing that. Now we've got to put in the values 2 and minus 1. So we've got to do the number work here. 2 to the power of 5. 2, 4, 8, 16, 32. Is that quick? 32 fifths. Plus 2 cubed is 8. 2 times 2 is 4. Minus, put the minus 1 in here. Now then, you've got minus a fifth. You've got minus 1 and minus 2. Let's try and work this out. 32 fifths minus a fifth is 33 fifths. Here I've got 12, and here I've got minus 3, but I'm taking away minus 3, so add another 3 here. Now let's try and put this, either go into fifths, or you could think about this one here. Look, you can work that one there out. 33 fifths. Well, 30 divided by 5 is 6, so I've got 6 and 3 fifths here. Plus the extra 15, I've got 21 and 3 fifths, or 21.6. The next bit is to find the area of this. Means I've got to roll up again, but let's show you this here. This shape here, a few people thought it was a triangle, but it's not a triangle. This shape here is a trapezium. And we should know, or should be able to sing our trapezium rule. It's half the sum of the parallel lines times the distance between them. That's the way you find the area of a trapezium. Well, how far apart are they? Well, it's going from 1 to 2 here, minus 1 to 2 here, so it's 3 apart. This one here is 6 high from here, and it's 30 high from that. So, half the sum of the parallel lines. 30 add 6 is 36. Half of it is 18, times the distance between them, times 3. 18 times 3 is 54. I've got 2 students that couldn't do 18 times 3. So the area we want is 54. Take away the 21 and 3 fifths that we had earlier, and the area that we're left with here then is 32 and 2 fifths. Again, I've had some students that got all the way down to there and then couldn't do the takeaway. You can't make negative slips in a Core 1 paper like that. Long question there, sorry, quite a long video, but there's the marking scheme, and here's the examiner's report. Mentioning down here, a lot of people tried to do that area of trapezium by integrating under the straight line. Far too much work. Really just do the area of trapezium. Try to remember that formula. Sing it to yourself.